This is Apollo Saturn Launch Control. We're T-minus 1 hour, 29 minutes, 57 seconds and counting. Finishing up at this time is the checks of the emergency detection system. Skip Chauvin, the test supervisor, now also making the spacecraft test supervisor, making some checks with the various members of the team launch crew inside the spacecraft. The boost protective cover has now come closed. This is the cover which will protect the spacecraft hatch, both from the jettisoning of the launch escape system and also as it develops some friction as it goes up through the heavy Earth's atmosphere. The crew now, as they prepare the boost protective cover, will also be going around the white room, doing what's called breaking up the white room, or generally preparing it for retraction. Once the closeout crew departs the white room area, that white room will be retracted to a standby position. It will remain in that standby position down through the countdown to the T-minus 5-minute mark, at which time it will come back to the fully retract position. Now T-minus 1 hour, 28 minutes, 52 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control, T-minus 1 hour, 19 minutes, 58 seconds and counting. At this time, the closeout crew has reported from the white room that they are in the last stages of clearing out the white room and making it ready for its retract position. Also going on at this time are some computer checks with the launch vehicle. These computer checks will be run continuously throughout the final portion of the countdown to ensure that the ground computers are communicating properly with the computers aboard the space vehicle. The launch crew had been having some problems with a vent valve in the first stage of the liquid oxygen tank. As mentioned earlier, the liquid oxygen, as it does boil off, is vented to the atmosphere. One of these vent valves appeared to be sticking. That problem now does appear to be solved as it has been brought closed. Now T-minus 1 hour, 19 minutes, 8 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control, T-minus 1 hour, 9 minutes, 59 seconds and counting. At this time in the command module Odyssey, the three crewmen, spacecraft commander Jim Lovell, command module pilot Jack Swigert, and lunar module pilot Fred Hayes are very busy. The spacecraft commander and command module pilot are configuring the stabilization and control system for liftoff and aligning that system with the guidance platform aboard the spacecraft. Also going on at this time is a check of the large propulsion system engine below the service module. This engine can be gimbaled in response to commands. This is done in two ways, and these systems are being checked out at this time. There is a thumb wheel control which can set the engine to a preset position for certain maneuvers, and also a rotational hand controller which can be used for the actual flight of a maneuver. These checks are being made now, the engine being gimbaled, with spacecraft commander Jim Lovell indicating the position that he is putting these to, and readouts are being made to ensure that the engine is gimbaling in proper response. Also at this time, a final checkout by the crew of the entry monitoring system. Also a final setting of this system. Our countdown proceeding well at this time, T-minus 1 hour, 8 minutes, 40 seconds. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We're just passing the 1 hour mark in our countdown. Now in the final hour of the countdown toward the launch of Apollo 13. The closeout crew has now left the white room area and will be standing by for the retraction to the 12-degree position of swingarm number 9. We've received word from the distinguished guest site that the stands over there are near capacity with some 4,500 guests in the area. The Vice President of the United States, Spiro Agnew, and Chancellor Willy Brandt, his special guests, have arrived in the area, although they are not at the stands yet. Out on the causeway at a guest site, we have 7,000. This is the largest guest number that we have ever had on our causeway site. To recap our countdown, which has proceeded very well today, we resumed the count after a 9 hour and 13 minute built-in hold at 4:13 a.m. this morning. At that time, the cryogenic loading began. This is loading aboard the extremely cold liquid oxygen and liquid hydrogen. Liquid hydrogen is the fuel for the second and third stage. Liquid oxygen, the oxidizer used on all three stages. RP1, or rocket propellant number 1, is the fuel used in the first stage. It is a kerosene-type fuel and was loaded before the countdown demonstration test back in mid-March. The cryogenic loading went well. There's over 800,000 gallons of cryogenics loaded aboard the Saturn V vehicle at this time. We entered a 1 hour built-in hold. This is a planned hold at the T-minus 3 hour and 30-minute mark. The crew was alerted this morning, shortly before 9 a.m., by Colonel Tom Stafford, Chief of the Astronaut Office. They then proceeded for a short or brief medical examination by Dr. John Teagan and Dr. Alan Harder. They were pronounced in good shape and ready for their flight. They then had the traditional breakfast of steak and eggs, tenderloin steak, eggs, orange juice, coffee, jelly, and toast. After a brief mission briefing, they donned their spacesuits and took the 8-mile trip in the transfer van to the pad area. They have now been in the spacecraft going through a variety of tests and checks, going over all their switch lists and so on. Our weather at this time is better than had been predicted earlier. We're still looking for some clouds to move into the area, and we'll be expecting a temperature of approximately 80 degrees at our launch time. We continue counting down toward a launch time of 2:13 p.m. Eastern Standard Time. Now at T-minus 57 minutes, 15 seconds and counting, this is Kennedy Launch Control. This is Apollo Saturn Launch Control, T-minus 55 minutes and counting. T-minus 55 minutes and counting, and the countdown continues to go well here at the Kennedy Space Center. The closeout crew has now left the White Room. We're standing by for the retraction of the swingarm. Swingarm number 9, that's actually scheduled to come at the 43-minute mark in the countdown. However, the closeout crew did leave somewhat early, so that event could come a little bit early than scheduled. Now we'll go to the Manned Spacecraft Center in Houston, Texas for a status.
This is Mission Control Houston. At the present time, the flight controllers here in Mission Control are monitoring the countdown and the status of the crew, the launch vehicle, and the spacecraft. The worldwide manned spaceflight network is up and ready to support the launch. We do have a problem with the Vanguard tracking ship downrange in the mid-Atlantic. A tracking data processor, we understand, is down on the Vanguard, and we will not get high-speed radar tracking unless this problem is cleared up. The Vanguard is a desirable element of the tracking network, but is not essential, and we're going to continue the launch with that problem. Just a few minutes ago, Ken Mattingly, who until a few days ago was the prime command module pilot for Apollo 13, arrived in Mission Control. Ken will be assisting at the Capcom console, and he's joined astronaut John Young and astronaut Joe Kerwin on the Capcom console. As he arrived in Mission Control, Flight Director Milton Windler greeted him and said, "Sorry to see you here, Ken." This is Mission Control Houston at T-minus 53 minutes and 20 seconds.
This is Apollo Saturn Launch Control, T-minus 49 minutes, 58 seconds and counting. At this time, we're making some preparations for range safety command system checks. These checks are of the system aboard the launch vehicle, which could be used by the range safety officer to destroy the vehicle should it stray off its intended course. These destruct actions, of course, would not be taken until the astronaut crew had been advised and were safely away from the vehicle. We're also standing by to wait for swingarm 9 to retract. That should be happening within the next 5 or 10 minutes. The countdown continuing to move along nicely in the last hour now, T-minus 49 minutes, 20 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control, T-minus 45 minutes and counting. T-minus 45 minutes and counting. Preps are now underway for moving the swing arm back to the 12-degree or park position. Launch site recovery forces have called in at this point and have indicated they're on station and ready to support the launch of Apollo 13. The prime crew inside the spacecraft at this time left the manned spacecraft operations building at Kennedy Space Center at 11:07 a.m. Eastern Standard Time this morning on their way out to the pad. They took the 8-mile trip in the transfer van, went up to the White Room level where spacecraft commander Jim Lovell was the first one to board the spacecraft at 11:32 a.m. He was followed by the lunar module pilot, who moved in. Fred Hayes moved into the right-hand seat at 11:32. The command module pilot stood by in the elevator with a suit technician, was the last one to come aboard. He came aboard at 11:44 a.m. Eastern Standard Time. We're now standing by for retraction of the White Room. That should occur in approximately 47 seconds. When it comes back, it will come back to a 12-degree or standby position. From this position, it can be quickly brought back to the command module if there is a need for the crew to egress or if we need to get a team into the crew. At the T-minus 5-minute mark in the countdown, the swing arm number 9 will come back to the fully retract position, and it will then stay in the fully retract position throughout the launch. Once the White Room has been moved back to the 12-degree position, the launch escape tower above the command module will be armed. Now standing by for the movement of the swing arm 9 some 5 seconds from this time. T-minus 43 minutes and counting, and swing arm 9 should be coming back. Swing arm 9 moving back now to the 12-degree position. It's about some 10 feet now from the spacecraft. We now have word that the Vice President, Spiro Agnew, and the Chancellor of West Germany, Willy Brandt, have arrived at the distinguished guest site. Now T-minus 42 minutes, 31 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control, T-minus 39 minutes, 57 seconds and counting. At this time, the command destruct system tests are now underway with the launch vehicle team. The launch escape system above the command module has now been armed, and that escape system now would be capable of lifting the command module free of the launch vehicle should a problem arise. A correction to the last announcement, the lunar module pilot Fred Hayes entered the spacecraft at 11:38 a.m. Eastern Standard Time this morning. Our countdown proceeding at this time, T-minus 39 minutes, 24 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control as we move into the final half hour of our countdown. T-minus 29 minutes, 56 seconds and counting. The Brevard Sheriff's Department, Brevard County, Florida, has reported that along Route 1, the closest major highway to Kennedy Space Center, there are some 100,000 people and 25,000 cars parked watching for the launch of Apollo 13. Along the Indian and Banana Rivers, it's reported that both rivers are literally filled with boats and spectators standing by to watch the launch. A private airport in Brevard County also reports some 500 private planes have landed and are parked at the airport. Our countdown continuing now. The power transfer test underway. T-minus 29 minutes, 13 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We're at T-minus 25 minutes and counting. T-minus 25 minutes and counting, and that critical launch vehicle power transfer test has been successfully completed. The lunar module will remain on internal power for approximately 10 minutes while the instrumentation aboard the lunar module is thoroughly checked out. It will then be deactivated and won't be reactivated again until the men enter the lunar module on their trip to the moon. As the Apollo Saturn V sits on the pad at this time, it's 214,369 nautical miles from their destination, the moon. Now, T-minus 24 minutes, 20 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control, T-minus 19 minutes, 59 seconds and counting. Now it's passing the 20-minute mark in our countdown, and the spacecraft test supervisor has indicated that they're running just slightly ahead of that in their countdown. The command module pilot, Jack Schweikert, is now pressurizing the service module reaction control system. This is the system on the service module, which consists of 4 quadrants with 4 engines each. Each one of these develops 100 pounds of thrust. He's arming these systems by letting the hypergolic fuels, these are monomethyl hydrazine and nitrogen tetroxide, flow down through the system down to the final valves. Hypergolic fuels ignite on contact, so once those final valves are open, they would ignite and the system would be activated. Schweikert also reading out the temperatures and pressures of that system. The countdown moving along well at this time, T-minus 19 minutes, 4 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control, passing the 15-minute mark, T-minus 14 minutes, 57 seconds and counting. Chill down of the second stage, or S2 stage, start tanks is in process. This is necessary to prepare those start tanks for the flow of the liquid hydrogen and liquid oxygen. The S2 or second stage will ignite at some 2 minutes 46 seconds into the mission if all goes as planned. The crew has been relatively quiet, answering the spacecraft test conductor, Skip Chauvin, in a terse, business-like manner as he questions them on certain switches and checks. In the distinguished guest site, the Vice President, Spiro Agnew, the Chancellor of West Germany, Willy Brandt, and the Secretary of State Rogers, all with a large crowd over there awaiting the launch of Apollo 13. Our countdown continuing to go well at this time. The spacecraft is now going to full internal power. Up to this point, it's been sharing its power load with the fuel cells aboard the spacecraft with an external power source. Also being carried out at this time is a AstroComm launch circuit check. This is the circuit that's used by the astronauts, the spacecraft test conductor and launch operations manager, and the Capcom Stoney, or Paul Weitz, here during the launch phase of the mission. Now T-minus 13 minutes, 33 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control, T-minus 9 minutes, 58 seconds and counting. The third stage start tanks are now beginning their chill down. The third stage scheduled to ignite at 9 minutes, 22 seconds into the mission. Also going on at this time is one of the computer checks which are carried out throughout the final portion of the launch. This particular one is a checkout of the launch vehicle digital computer to ensure that it's ready for launch. A final check of the weather indicates that earlier worries about the weather have come to naught. Weather looks good and is satisfactory, presents no constraint to our launch. Now T-minus 9 minutes, 25 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control, T-minus 5 minutes, 27 seconds and counting. Now as we move into the final phase of the countdown, we're receiving go, no-go checks from various elements of the launch team. The spacecraft test conductor, Skip Chauvin, gave the test supervisor a spacecraft ready. At that time, on our large status board here in the firing room, the green light came on behind the spacecraft. Green light now is also on behind the emergency detection system. Now standing by for more checks, the mission director, Chet Lee, from the Manned Spacecraft Center in Houston, says we are go for launch, and the range indicates the range is ready to support. Chill down of the S4B stage. Chill down of the S4B stage being completed at this time. The S4B will ignite into the mission at 9 minutes, 22 seconds. Swing arm number 9 now is retracting to the full retract position. Swing arm number 9 coming back to the full retract position. And the Director of Launch Operations, Walt Caprian, has given Apollo 13 a go for launch. We're now approaching the 4-minute mark. At the T-minus 4-minute mark, we'll be standing by for Jack Baltar, the launch vehicle test conductor, to say that his launch vehicle team is ready to carry out the final phase here of the countdown. At the T-minus 3-minute 7-second mark, we will get the ignition sequence start. This will put us on an automatic sequencer, and the remainder of the count from that time will be on automatic. The sequencer can check out literally hundreds of items in the space vehicle. At the same time, the team here in the Launch Control Center will be monitoring red line values. These are such things as temperatures and pressures, which we do not want to either go above or below. Final communications checks now. The astronauts on the Astrocom circuit, and Launch Operations Manager Paul Donnelly, during his final check, said, "Good luck, head for the hills." He was referring to the hilly Frau-Morrow region of the moon. As we come up on the T-minus 3-minute mark at 3 minutes, the capsule communicator, Paul Weitz, will begin reading out the minus time to the crew. Looking up at our status board now, we can see that the spacecraft, or the first stage preparations, are now complete. The firing command has now been initiated. This is the automatic sequencer, and we have a confirmation on our status board that the launch sequence has started. We're now in our final 3 minutes of the countdown, 2 minutes 56 seconds, and Apollo 13 continues to be go. The astronauts still reporting back from the spacecraft Odyssey. Spacecraft Commander Jim Lovell says Odyssey is go. He will be the last one to perform a function here during the countdown. At the T-minus 45-second mark, the Commander Jim Lovell will set the final alignment of the spacecraft guidance. That's the last crew action before the liftoff of Apollo 13. We continue to aim for a liftoff at 2:13 p.m. Eastern Standard Time. Now T-minus 2 minutes, 18 seconds and counting, and our count continues to look good. Our weather is no constraint to launch today. Earlier fears about the weather seem to have dissipated. A stationary front over the Florida-Georgia border has not sent down the predicted bad weather that we had feared. We just passed the 2-minute mark, in the countdown, and the pressurization now of the vehicle tanks is beginning. The third stage liquid oxygen tank has now been pressurized, and the second stage liquid oxygen tank has been pressurized. We'll be making our final transfer from external power source, that is from the external power source at the pad, to the launch vehicle batteries at the T-minus 50-second mark. We'll be keeping an eye on that power transfer at T-minus 50 seconds. The S4B propellants now all pressurized. S4B propellants, that's the third stage of the Saturn V, pressurized. 1 minute, 15 seconds, and counting. The spacecraft equipment now is on its own internal cooling. It's been sharing its cooling getting its cooling from an external power source up to this time. We're now approaching the T-minus 1 minute mark. T-minus 1 minute, T-minus 1 minute, and counting. Now in the final minute of our countdown. At the 30-second mark, swing arm number 1 will retract. T-minus 50 seconds. As we pass the T-minus 50-second mark, the power transfer takes place. First stage, second stage, third stage, and the instrument unit going to internal power. T-minus 37 seconds, and our count continues to go well. We'll be looking for an ignition of those 5 first stage engines at the T-minus 8.9 second mark. We've passed T-minus 30, T-minus 25 seconds and counting, and Apollo 13 is go. T-minus 20 seconds, T-minus 20 seconds and counting. 17, guidance release, 15, 14, 13, 12, 11, 10, 9, 8. Ignition sequence has started. 6, 5, 4, 3, 2, 1, 0. We have commit, and we have liftoff at 2:13. The Saturn V building up to 7.6 million pounds of thrust, and it has cleared the tower.
This is Mission Control Houston. We appear to have a good first stage at this point. Flight Dynamics Officer says the trajectory looks good. We show 1/2 mile in altitude at this time.
13 Houston, go at 30 seconds.
Roll complete and we're pitching.
Roger that. Stand by for mode 1 Bravo. Mark 1 Bravo.
1 Bravo. Command.
Altitude 1.2 miles, velocity 1,500 feet per second.
Houston, go at 1. We show the cabin relieving.
13, roger.
And at 1 minute 10 seconds, we show an altitude of 4.1 nautical miles. Downrange 1 mile. All sources continue to report we're go. The trajectory on our plot boards is right on the pre-planned line. And the booster engineer reports we're now through the region of maximum dynamic pressure and we're go.
Houston, stand by for mode 1 Charlie. Mark, you're 1 Charlie.
Mark, 1 Charlie.
And 13, you're go for staging.
Go for staging, roger. We're EDS manual.
Altitude now 17 miles, coming up on staging.
Step forward.
Jim Lovell reports the inboard engine has shut down as scheduled.
We confirm inboard out 13, you're looking good.
Roger.
Coming up on 30 miles altitude.
S2 ignition.
Roger. Houston, trajectory's good, thrust is good.
Roger.
Capcom Joe Kerwin confirming to the crew that the second stage looks good at this point. We're now 46 miles high, 78 miles downrange.
Skirt. Tower jet.
We confirm skirt SEP, roger tower jet, mode 2, Jim, looking good.
Mode 2.
Launch vehicle. And Lovell reports that the guidance system is correcting the small errors.
13 Houston, guidance is good and the CMC is go.
Okay, thank you, 13, Joe. Roger.
Coming up now on 4 minutes. We're now at an altitude of 63 miles. At 4 minutes 15 seconds, the trajectory.
Your go at 4 minutes, so little red lines are right on the little white lines down here.
Sounds good.
Velocity up now to 11,000 feet per second. That's about 36% of the amount needed for a minimum orbit. We're now 75 miles in altitude. ...222 miles downrange now. The ECOM reports...
Up 5 minutes, you're looking perfect, over.
13, roger.
And our ECOM reports that the cabin pressure is sealed at 6.1 pounds, which is normal. We're now 250 miles downrange, altitude 81 nautical miles. And at 5 minutes 30 seconds into the launch, we continue to look very good on the second stage, Jim Lovell just reported the inboard engine is shut down as scheduled.
'13 Houston, stand by for S4B to COI capability.
S4B to COI, roger.
Roger, you've got it now, Jim.
We've got S4B to COI.
Booster reports that the inboard engine shutdown was a bit early. We're continuing to burn on the 4 outboard engines.
13.
Go 6. And Houston, what's the story on engine 5?
Jim, Houston, we don't have a story on why the inboard out was early, but the other engines are go and you're go.
Roger.
At 6 minutes 40 seconds.
Still looking good, your gimbals are good, trim is good.
Roger.
'13 Houston, level sense arm time 8+38 nominal, S2 cutoff time 9er plus 48. Over.
Roger, nominal on the level sense arm, 9er 48 on the S2 cutoff.
That's affirmative, and stand by for S4B to orbit. Mark, you have S4B to orbit, Jim.
Roger, we have S4B to orbit.
We still have 4 good engines on the Saturn second stage. We show an altitude of 96 nautical miles, 545 downrange. And at 7 minutes 45 seconds, booster reports we are go. All 4 engines remaining looking good. The early shutdown of the center engine would cause no problem. We would burn a little bit longer than normally scheduled.
Houston looking good at 8 minutes.
13, roger.
And at 8 minutes 17 seconds, we show a velocity of 18,000 feet per second. That's about 71% of the amount needed for a minimal orbit. At 8 minutes 35 seconds, continuing to burn on the second stage. All 4 remaining engines looking good at this point.
Apollo 13 Houston, mark level sense arm.
Mark level sense arm, roger.
Apollo 13 Houston, at 9 minutes, you're go, the CMC is go.
Okay, Joe. 13, roger.
Our predicted shutdown time on the second stage is 9 minutes 48 seconds. Flight Director Milton Windler getting a staging status now from his flight controllers.
13 Houston, you are go for staging.
13, roger, go for staging.
Apollo 13 Houston, stand by for mode 4 capability. Mark, you have mode 4, Jim.
Mode 4, roger. Staging.
And level report staging.
And S4 ignition, Houston.
Roger that, Jim. Thrust looks good.
Roger.
Houston, you're looking good. Trajectory guidance, CMC are all go.
Thank you, Joe.
And at 10 minutes 30 seconds, we are now 102 miles in altitude, 1,080 miles downrange.
13 Houston at 11 minutes. Your go. Predicted cutoff on the S4B is 12 plus 34, over. Apollo 13 Houston, your go at 11 and a half, and predicted cutoff time is 12 plus 34, over.
Understand, 12 plus 34 predicted cutoff time.
That's affirm.
Coming up on 12 minutes, still looking good. We're standing by now for a crew report of third stage shutdown.
Seco.
Copy Seco, Jim. We're looking at the diski.
Roger.
And the flight dynamics officer says at first glance we look good on the orbit.
Apollo 13 Houston, you have a go orbit all sources and the booster is safe, over.
Go orbit and the booster is safe. Thank you, Joe.
Don't mention it. Houston, we copy your ground 44.
Yep. Okay, Joe.
The booster engineer reports at this time that the S4B third stage looks good, being configured now for orbital operations. We're standing by for a confirmation from the flight dynamics officer of our preliminary orbit.
Apollo 13 Houston, your preliminary orbit down here is 102.5 times 100.3 and everything is looking good.
Roger, Houston, and it looks good to be up here again.
I'll bet. Apollo 13 Houston, I have your Z torquing angle. You ready?
Jack's ready to copy, Joe.
Okay, it's plus decimal 26, over.
Okay, Joe, plus 0.26.
That's Roger.
This is Mission Control at 17 minutes. We've had loss of signal with the spacecraft. We'll be reacquiring shortly through the Canary Island tracking station. The total burn duration on the third stage was about 45 seconds longer than planned. We would not expect at this point that this would have any serious effect on the trans-lunar injection. The fact that we did consume a bit more propellant out of the third stage than was originally planned. We're standing by now for acquisition of signal through the Canary Island station. We should be reacquiring radio contact with the spacecraft shortly. This is Apollo Control. We're still standing by for any conversation with the spacecraft over Canary Islands. The booster systems engineer reports that at this point he has no explanation for the early shutdown of the S2 Saturn second stage center engine.
Go ahead, Houston.
Okay, a couple minutes to LOS, Jim. Everything is looking real good. Your AOS time at Carnarvon will be 52:36. And we don't have too much of a handle on why the inboard cut off early, except that it apparently was an engine problem and not a switch select function. But we're certain that you'll be able to make TLI based on what we're looking at now.
Roger, nothing like an interesting launch.
That's right. Apollo 13 Houston, Canary LOS in 30 seconds. Request command reset, please.
Roger, command reset, come up.
Thank you. Apollo 13 Houston, request low bit rate, please, over.
Low bit rate.
This is Apollo Control. We've had loss of signal now with the spacecraft at the Canary Island tracking station. We won't reacquire again until the spacecraft reaches the tracking station at Carnarvon, Australia. That will be at a ground elapsed time of 52 minutes 36 seconds. Recapping, at the time we lost contact with the spacecraft through Canary Islands, we look to be in very good shape for the trans-lunar injection burn with the Saturn third stage. The second stage center engine shut down about 2 minutes early. The total overburn time on the third stage was about 10 seconds. And we don't expect that this would have any effect on the trans-lunar injection. At 25 minutes 20 seconds, this is Mission Control, Houston. This is Mission Control, Houston at 52 minutes. We're standing by now for acquisition of signal, and our network controller reports we've just reacquired the spacecraft over the Carnarvon station.
And how do you read 13?
13 Houston, loud and clear.
Okay, Joe, everything's going good. We're proceeding on the timeline in good fashion. I've got a P-52 done. I can give you the torquing angles.
I'm ready for him, Jack.
Okay, use now 26, stars 26 and 33. The star angle difference was all balls. Now 93 minus 067 minus all balls plus 0.162. The time of torquing was 45 minutes, 35 seconds.
Well, that sounds marginally acceptable.
For a new CMP, it ain't too bad.
Yeah. Okay, 13, we got nothing for you at the moment. Everything's looking good. We're looking at your data now.
This is Mission Control at 57 minutes 15 seconds. Not much conversation with the crew on this pass over the Carnarvon tracking station. Jack Swigert reported that the platform had been aligned as called for in the flight plan. There's not a great deal of activity scheduled in the flight plan at this time. Flight Director Milton Wendler has checked the status with his flight controllers, and Capcom Joe Kerwin will be passing that up to the crew shortly.
Apollo 13 Houston, LOS Carnarvon in about 30 seconds. Honeysuckle on the hour, and verify your S-band is up for Honeysuckle, over.
That's verified.
Roger.
And Houston, we're beginning to see a beautiful sunrise here.
Roger that, Jim.
We've had loss of signal now with the spacecraft through Carnarvon. Apollo 13 will be coming within range of the tracking antennas at the Honeysuckle Creek, Australia station in less than a minute. We'll stand by for reacquiring. And at 1 hour, 10 minutes into the flight of Apollo 13, we should be reacquiring radio contact with the spacecraft through Honeysuckle Creek momentarily. Recapping briefly the situation during the launch, we had a normal first stage burn. The second stage ignition was normal, up through 5 minutes and 30 seconds, at which time the inboard engine, engine number 5, shut down early. The center engine had been scheduled to shut down at about 7 minutes and 44 seconds ground elapsed time. The cutoff on the second stage was at about 9 minutes 48 seconds, about 30 seconds early, and the total excess burn time on the third stage was about 10 seconds. Capcom Joe Kerwin has just put in a call to the crew. We've had acquisition of signal. We'll stand by for conversation with the spacecraft.
13 Houston through Honeysuckle.
Roger, Houston, 13 here, reading you loud and clear.
Okay, S-band sounds good, Jim. Go ahead, 13.
It'll be okay if I crank up the FM.
You're coming in weak. I didn't quite copy it.
It's going to be okay, Joe, if we crank up the FM after we leave Honeysuckle here.
Oh, stand by on that one. Houston.
Go ahead, Houston.
What TV was that? Okay, 13.
Okay, Joe, I just wanted to put on the TV switch at Honeysuckle to tune her up there.
Roger, I'm being prompted, and you've got to go for that. You can turn it on, go to TV, and we'll see you that way over the States.
Okay.
Okay, 13 Houston, LOS Honeysuckle in about 30 seconds, and we'll see you over the States at 1 plus 28 plus 43. Houston, did you copy your AOS time?
We've had loss of signal now from the spacecraft. At last look, everything appeared to be normal with the spacecraft and the launch vehicle. We currently show an orbit of 103.2 nautical miles. Actually, correction on that, 102.6 by 106.3, and our current altitude is 103.2. We'll be reacquiring the spacecraft over the United States at the ground elapsed time of 1 minute 28 minutes 43 seconds, at which time you heard the crew advise that they will be configured for the TV transmission, which is scheduled to occur at about 1 hour 36 minutes over the Mila station. The post-launch press conference is scheduled to begin shortly at Cape Kennedy. At 1 hour 7 minutes, this is Mission Control, Houston.
Okay, we're back here at the Kennedy Space Center now, and I guess we're ready to proceed. We're going to attempt to conduct this post-launch conference between communications with the spacecraft. This gives us approximately some 20 minutes. We'll do our best to try and get as many questions in that time, but I'll be standing by for a signal also so we can go back to air-ground at the proper time so that you can keep up with every phase of the mission. At this point, I'd like to introduce Mr. Walter Caprian, Director of Launch Operations for the Kennedy Space Center and Launch Director for Apollo missions.
Good afternoon, ladies and gentlemen. It's a pleasure to see you on a clear day for a change. I guess there really isn't too much to report to you as far as the countdown itself is concerned. It was perfectly nominal. We had no problems whatsoever with the spacecraft, with one exception, and that was in that we do have a lock to safe our pyro bus, and it takes a key to remove that lock, and we broke the darn key off in the lock, and it took us a little while to get it out. We did have a spare key, and we took that off, and that's the sum and substance of our problems with the spacecraft. At approximately 1 hour and 50 minutes before launch, we did run into a little difficulty with a LOX vent valve in the S1C stage, which we were attempting to cycle open and close as required for the venting process, and it stuck on us in the full open position, and we ran through a repeated number of cycles attempting to free it, and for some time we're unsuccessful in doing so. It causes concern in that if we had not been able to close the vent valve, we would not have been able to pressurize the LOX tank at T-minus 72 seconds. However, we did run some nitrogen gas through the system, and we were able to sufficiently raise the temperature such that we were able to close the valve, and we proceeded the rest of the way with that vent valve in a closed position at all times. And we do have a second vent valve in the stage that we relied on to give us the correct conditions at time of stage pressurization at T-minus 72 seconds. Those two items were the sum and substance of the problems that we encountered during the entire countdown. As most of you know by this time, the first stage burn was perfectly nominal. You may have noticed that it seemed almost like an eternity before the vehicle cleared the tower. Well, that, of course, was because this is the heaviest vehicle that we've flown. It was approximately 26,000 pounds heavier at liftoff than Apollo 12, and the S1C engines, though they were perfectly within specification, were rated at about 100,000 pounds total thrust less than those that we had on the Apollo 12 vehicle. This made the time about 1/2 to 3/4 of a second longer in clearing the tower. All of the first stage burn, as I mentioned earlier, was perfectly nominal. The second stage burn was nominal up until the time that the S2 inboard engine cut off. That engine is normally cut off by a switch selector command approximately 90 seconds before the outboard engines are cut off. for some reason that we have not been able to determine at this time, the engine did cut itself off approximately 2 minutes earlier than planned. Now, as a result of that having happened, the outboard engines, of course, burned approximately a half a second longer. They burned to fuel depletion and made up some of the energy that was lost by virtue of the inboard engine having cut off early. And when we burned the S4B, it burned approximately half a minute longer than originally planned in order to make up the deficiency. And at the end of the first burn of the S4B, the deficiency was made up. Now, we had approximately a 2,200-pound payload margin for this mission. We used up a little bit of that margin by the fact that the engine did cut off early, but we did not use up enough to lose any confidence in our ability to perform the TLI maneuver. We still do have a 3 sigma capability. So we have no reason to suspect that we will not have a good TLI burn and fly a perfectly nominal mission from this point on. I guess that's all I have in the way of general comments. Feel free to ask any questions if you choose to.
Hey, Dick, right down here.
Why did we nominally have main stage engines lower rated than thrust, if I understood you correctly?
They weren't, well, you know, the vendor guarantees engine performance to a certain specification. These engines did meet that specification. It just so happens that they weren't quite as hot as the ones we flew on Apollo 12. There's nothing wrong with them. I don't mean to imply that. I'm just explaining to you why it took a little longer to clear the tower than it had taken on previous missions.
Up there. Go ahead.
Does the longer time for the S4B burn affect the timeline at all?
I don't think it affects it significantly. I think we're going to be within seconds, certainly not more than a minute or two.
Go ahead, Sanders.
Do you have that total liftoff weight, since it was the heaviest, other than 26,000 more than the other?
No, I don't. It was, if you recall what Apollo 12 was, add 25,600 pounds to it.
It was about 6.4, but we'll check that figure for you. Al, all right, go ahead. Okay. Go ahead. Go ahead, Reg.
You told us there was a 22,000-pound payload margin.
2,200 pound.
200, thanks. How much of that margin has been consumed, please?
The best we can determine, we used up a significant proportion of that margin. Now, beyond that margin, we still have what we call a 3 sigma capability. So we have the full 3 sigma capability plus somewhat of a margin. And at the time I left the firing room, we did not have all of the numbers in yet telling us exactly how much we had, but we're able to establish that we did have the full 3 sigma margin. The 2,200 pounds was something that was a little bit of gravy that we had in addition to that.
But is it a fact that you've just got enough for TLI now?
Yes. For a 3 sigma condition. In other words, for a worst case condition. If you put all of your 3 sigma errors together, which is the basis on which we plan our missions, we have enough reserves to handle that.
Thank you.
We still have margin, put it another way.
We have all the margin we wanted to have.
We have not used up all our margin or even come close to using it.
We have our full 3 sigma margin.
Sanders?
On that weight again, where do you get in the extra 22,000 pounds? Is that fuel, and if so, located where?
As far as the margin itself was concerned, well, we flew with some extra propellants aboard this vehicle, part of it for the reason of flying this mission and part of it to just get a little bit of added knowledge as a preliminary to flying the J missions, which are going to be missions where we fly with heavier payloads than we've been flying to this time. So we loaded the tanks up more than was required to fly the mission.
Go ahead up there.
Do you have enough fuel left to guide the S4B for the lunar impact?
I asked that question when I left the firing room. The best answer I could get at that time was that we should not affect our capability of flying the nominal lunar impact with the S4B. In other words, we expect to impact the S4B where we had planned to.
Ed, over here.
Well, that's the same question I wanted to ask.
Do you have any over here? I don't see any more hands. Okay, we'll take two over here and then we'll wrap it up.
Mattingly was in the control room. Was there no concern about his being infectious with German measles?
He was in the control room in Houston.
Mattingly left the Cape last night.
I think we'll try to find that out for you, Ben, but I don't think we have any details. Ken Mattingly observed the launch from the Mission Control Center in Houston, not here. Did you have a question, Andy? Go ahead.
Could you give us the figures again for the additional burn of the S2 and the S4B?
Yes, the S2 inboard engine, the center engine, cut off 2 minutes and 7 seconds earlier than it was supposed to. As a result of that, the outboard engines burned 33.96, roughly 34 seconds longer than they would have had the inboard engine burn for its proper time. As far as the S4B is concerned, the delta in time was about the same, 33.97, roughly 34 seconds longer.
Okay, we'll take one here.
One last thing about this extra fuel, Walt. Did you have extra fuel in the S4B by any chance as a result of running this weight up, and did that give you a little more leeway?
Yes, we had some extra fuel in all three stages. We had about the same amount of LOX that we flew on Pete Conrad's mission. We had approximately 9,500 pounds more RP1 than we had on Apollo 12, and we had more LOX and hydrogen in both the other stages. I knew those figures, but I've forgotten them. I can't give them to you.
Did that make any difference in the 3 sigma?
Well, it helped us out.
Okay. All right, we'll take one final one up here.
Can we have exact liftoff time, please?
Well, let me check here.
Shows in the zone.
Here it is. It was 600 milliseconds late.
Two 213.00.6. Okay, thank you very much. That completes the conference. We should be coming back up on an acquisition in about 10 minutes.
There's one thing I said that I'm not sure I knew what I was talking about and what it does to the timeline.